Your next reading is capital budgeting, and questions are from your end of chapter curriculum. First question: the net present value of an investment is equal to the sum of the expected cash flows discounted at what? Not internal rate of return, because internal rate of return is the rate at which the NPV is 0. It is the rate that is generated by the project. So this is not right. We do not discount the projects at risk-free rate. Very rare, unless the project has absolute certain cash flows. Yes, opportunity cost of capital. Yes, that's correct option C. That's what we may use as one of the options to use as discount factors. Next. A 2.2 million investment will result in the cash flows shown below. This is your initial investment, cash flow at year 0. It's negative 2.2 million. Then cash flow in year 1 is 1.3 million. Enter down arrow key twice. 1.6 million at the end of year 2. 1.9 million at the end of year 3, and finally 0.8 million at the end of year 4. What are we required to calculate? Using 8% opportunity cost of capital, the project's net present value is to be calculated. So what you will do, simply plug in the numbers. 2.2 1.3, enter down arrow key twice. 1.6, enter down arrow key twice. 1.9, enter down arrow key twice. 0.8, enter down arrow key twice. Simply press NPV. The system will require the discount rate. 8, enter down arrow key CPT. It's 2.47 million. So that makes A to be the correct option, and as you can see, A it is. Next, the internal rate of return is best described as what? Internal rate of return, as we discussed yesterday, internal rate of return is the rate at which the NPV 0, in other words, present value of inflows is equal to your present value of outflows or initial investments. So it's the rate, the discount rate, that makes the net present value equal to 0. That makes C to be the correct option. Next, a 3-year investment requires initial outlay of £1,000. It is expected to provide 3 years year-end cash flows of 200 plus a net salvage value of 700 at the end of 3 years. Its internal rate of return is closest to. So your cash flow at year 0 is £1,000. Enter down arrow key. Next, 200, enter down arrow key. Since there are 3 such cash flows of $200, so I would recommend to write frequency 2, and the third year 200 must be added with this 700 disposal proceeds, giving you a total of 900 at the end of year 3. So once you enter all these, press IRR, press CPT, you will get your. So your cash flow at year 0 is £1,000 negative. Then $200 or 200 pounds, enter down arrow key once. Frequency of this cash flow is 2. Enter down arrow key, then enter 900. Enter down arrow key twice. Press IRR CPT. It's 11.025. Now this is a good question. It involves calculation of NPV, IRR, calculation of payback period as well as discounted payback period. So we will use calculator for this, and rest of the questions we'll just simply move on and enter. Simply I will write down the notations and that's all. Given the following cash flows for a capital project, calculate the NPV and IRR. The required rate of return is 8%, 50,000 outflow at the start of the project, 15,000, 15, then 20, then 10 and 5. So what we will do, use these keys. 15,000 since it's twice, so enter down arrow key, 2, enter down arrow key. Frequency is 2. So then 20,000, enter down arrow key twice. 10,000, enter down arrow key twice, and then last 5,000. Then press NPV, 8%, enter down arrow key, press CPT. You will get your NPV and as well as IRR. So let's punch in the numbers. 50,000 negative, enter, down arrow key, then you have 15,000, enter twice, 20,000, then 10,000, and then 5,000. NPV discount rate is 8. $3.378.83, that's your NPV, so that perfectly matches with the option C. You can also calculate your discounted payback, that is 4.007. Your payback is 3. So in the same sequence of questions, same question, the discounted payback period we just calculated, it was 4.007, and the simple conventional payback is 3. So the difference between the discounted payback and the payback is 1.01. Right? So that makes C to be the correct option. Still we have to calculate the IRR, and I think it will be there. IRR 10.879. 10.879, so that makes 3.379 is your NPV, this is your IRR, and we calculated the payback and the discounted payback as well. Unfortunately, this is possible only in your BA plus 2 professional. I don't think so this function is available in your simple BA2 plus. So for that, what you will do, calculating payback is straightforward. Negative 50,000 plus 15 plus 15 and 20. 3 years is straight payback period, your simple conventional payback. For discounted payback, you will have to calculate the present value of all these cash flows, year 1, 2, 3, 4, 5, and then see where your negative is gone. Like this is 36,000, still after receiving this much cash at the end of year 1, 2, 3, 4, still not. We haven't yet recovered the complete investment made at year 0. Still we need $24 from the 5th year, so you're going to write 24 upon 3378. Whatever the fraction comes, need to add it in 4, give you 4.007, right? So we were required to calculate the difference between the payback and the discounted payback. So the discounted payback is 1.01 years longer than the payback period. So that is C. Next, an investment of $100 generates after-tax cash flows of 40 in year 1, 80 in year 2, 120 in year 3. The required rate of return is 20%. The net present value, I'm going to simply write down the notation. You'll simply enter it in your calculator. This is your initial investment. 40 in year 1, single cash flow. 80 in year 2, single, and 120 in year 3. And simply you'll press NPV, enter your discount rate, that is 20%. Enter down, press CPT, and you should get your NPV as 58.333. That makes B to be the correct option. Next, an investment of $150,000 is expected to generate an after-tax cash flow of $100,000 in year 1, 120 in year in 2 years. The cost of capital is 10. What is the internal rate of return? Simply enter CFO, not negative 150, enter down arrow key, then $100,000 positive, enter down arrow key, then 120,000, enter down arrow key, and then simply press IRR and press CPT, and you'll get your result 28.785, and that perfectly matches with your option C. Next, Kim Corporation is considering an investment of 750 million won with expected after-tax cash inflows of 175 million won per year for 7 years. So this cash flow is recursive for the next 7 years. The required rate of return is 10%. What is the project's NPV and IRR? So what you will do, cash flow to year 0 is negative 750. Enter down arrow key. Then 175, which is positive. Enter down arrow key. Frequency is 7 years. So you'll write 7, punch in 7. Enter down arrow key. Press NPV. The system will ask for the discount rate. Punch in 10. Enter down arrow key. Press CPT. You will get 101.973. which is approximately A. And then again, punch in IRR, press CPT, you will get 14.019, and that makes A to be your correct option for sure. Next, Kim Corporation is considering an investment. I think it's the same repetition of the same question. You have the numbers on your system. You will simply move the arrow key up or down. You will be able to calculate the payback period as well as the discounted payback period. If you don't want to use it, calculation of payback and discounted payback is very easy. It's not some exact science, so you can calculate it accordingly using your simple BA+2 calculator. B. An investment of $20,000 will create perpetual after-tax cash flows of $2,000. The required rate of return is 8%. What is the investment profitability index? There are two ways you can calculate profitability index. One is NPV upon initial investment. Other is 1 plus NPV upon initial investment. This basically is present value of inflows upon initial investment. So they will differ by 1. So first of all, we will have to calculate the present value of these cash flows, and since we are getting 2,000 in perpetuity, the required rate of return is 8%. It will give us $25,000. Since it is present value of the future inflows, so we are going to use this one. 25,000 upon 20,000 will be 1.25. Now, if you calculate NPV, so that's NPV will be 25 less 20, that is 5,000, right? So 5,000 divided by the initial investment will give you 0.25. See, if you use this formula, it will give you 0.25. 0.25 per dollar of investment, it will give you $1.25. So they will differ by $1. That was the point to be learned. Harman Corporation is considering an investment of 375 million euros with expected after-tax cash inflows of 115 million per year for 7 years. This is your frequency, and an additional after-tax salvage value of 50 million in the year 7. The required rate of return is 10%. What is the investment's profitability index? Again, we need NPV. Cash flow to year 0, negative 375, enter down arrow key, 115, enter down arrow key. But remember, we will take 6 years frequency for 115. Why? Because the 7th year 115 will be added in this 50 million, giving you a total of 165 at the end of 7th year, right? So 115, 6 has been taken here in this arrangement, and the last 115 will be added in the 50, so 165 at the end of 7th year. Now enter all these, press NPV 10, enter down arrow key, press CPT, and you should get 210.52. Gentlemen, this is NPV, which means profitability index can either be calculated with NPV upon initial investment. Let's see which value did he use. 210.52 upon 375. If you calculate, you will get 0.56. Clearly doesn't match. It means they might have used this one. Profitability index is equal to 1 plus this factor. So it is going to be then 1.56. So the only difference is that in this arrangement, we take present value of inflows upon initial investment. Here we take NPV upon initial investment. So nonetheless, the difference will be of 1. And the ranking of the project, various projects that you're analyzing, the ranking would be the same. If you have 3 projects to rank A, B, C, whether you use the first one or the second one, ranking would be the same. If B is the first in ranking, it will stay the first in the ranking, C the last. Whatever formula you use, ranking would stay the same. Next, question 13. Aaron Chow is reviewing a profitable investment project that has conventional cash flow pattern. Conventional cash flow means initially outflow and then ala tool inflows. If the cash flows for the project initial outlay and the future after-tax cash flows are doubled, Chow would predict that the IRR would be. Now interesting, let's say it's a 4 years project requiring $10,000 initial investment. Let's assume 5,000 inflow in the year 1, 7,000 in year 2, 5,000 in year 3, and let's say 15,000 in year 4. Okay, now what happens? All the cash flows are doubled. Your initial investment gets doubled. Your inflows get doubled as well. 14K and this 10K and then finally 30K. How would it affect your NPV and IRR? It's an interesting question. IRR measures the return per dollar of investment. IRR would stay the same because both initial and the inflows on per dollar basis, they are the same. You can try it out. You can use your calculator, plug in these numbers, your IRR would be the same. But since the inflows and outflows have been doubled, NPV will be doubled. You can try this, take it as an assignment. Use these numbers, calculate IRR first, NPV first with the first one, then double the numbers, calculate IRR and NPV. You will see that NPV will double with these arrangements. Right? So you can give it a try yourself. I've given you the conclusion. Next, Shirley Shia has evaluated an investment proposal and found that its payback period is 1 year. It has a negative NPV and it has a positive IRR. Is this combination of results possible? We can take any combination that makes sense in the given scenario. So I'm going to take the one that have been suggested in the solution. What we require is that the payback is 1 year, NPV is negative, but IRR is positive. Let's take $100 initial investment. We receive $100 in year 1 and $5 in year 2. Just to make sure that we get negative NPV, so our inflows present value would definitely be lower than $100. So that's why we will have negative NPV. And payback, since we want to recover the amount within 1 year, so we use these numbers. And try 10%. This is your initial investment, 100 inflow in the year 1, $5 in year 2. Use 10% discount factor. Let us do it. $100 negative, enter down arrow key. Then we have $100 positive, enter down arrow key twice, and $5 in the second year. NP for 10%. NPV is negative. Yes, it is. Negative 4.95. Negative NPV. Yes. Payback. Payback is 1 year. What about the IRR for this project then? I hope system stays. IRR is 4.77. IRR is positive. NPV is negative. And the payback is 1 year. You can use the combination of numbers to give you the payback within 1 year, 1 year, and not a longer project. So you will have the same arrangement, same comes. It is possible. It's perfectly possible. We have just checked using the numbers. So that makes A to be the correct option. Now this is an interesting one. A very good question. An investment has an outlay of 100 and after-tax cash flows of 40 annually for 4 years. Okay. A project enhancement increases the outlay by 15 and the annual after-tax cash flows by 5. As a result, the vertical intercepts of the NPV profile of the enhanced project shifts where? Okay, I think we should have drawn our own rather than using this one. So this is the arrangement, gentlemen. $100 initial investment, $40 you receive for the next 4 years means total info will be 160. If it's undiscounted at 0% rate, the NPV would be 160 minus 100, it will be 60. So NPV will be 60. For the purpose of IRR, you can plug in the numbers. You can take this, take cash flow to year 0, $100 negative, then $40 for the next 4 years, CPT, IRR, and I think you will get 21.86. You can try it out, 21.86. Now, what happens? The project enhancement increases the outlay by 15. It means your new cash flow at year 0 is 115, right? And the same time, annual after-tax cash flow increased by 5. So instead of 40, we have 45. right? Calculate your IRR. IRR for this arrangement, you know how to calculate. It's going to be 20.68. It means IRR will shift to the left. Now, what about the vertical axis, the y-intercept, where the graph cuts the y-axis, the NPV? Since now we have initial outflow of 115 and our annual cash flows are 45 times 4 plus less 115, it's going to be net 65. So it means your graph is going to be, your NPV profile is going to be like this one. It will move up $5 and the IRR will shift to the left. So what you will see, what you can verify this using numbers. So your NPV profile, it will shift upwards and horizontal intercept shifts left. From 21.86 IRR, it will fall to 20.68 and the vertical one will move from 60 to 65 up. So you can verify with the numbers. I've given you the keyboard combinations, your key combinations. Next. Project 1 and 2 have similar outlays, although the patterns of future cash flows are different. The cash flows as well as NPV and IRR for two projects are shown below. For both projects, the required rate of return is 10%. Right? The projects are mutually exclusive, which means either we can take project 1 or project 2, not both. What is the appropriate investment decision? Invest in both? We cannot, since they are mutually exclusive, either 1 or 2. Invest in project 1 because it has higher IRR. We discussed yesterday the pitfall of IRR. IRR can put you in trouble in mutually exclusive projects and in the projects with unconventional cash flows. So even it's a conventional cash flow, but IRR is rarely used alone for decision analysis, for investment decisions. So even it has higher IRR, our decision is based upon the NPV. Invest in project 2 because it has higher NPV, no computation needed. Go straight for C and there you go. Consider the two projects below. The cash flows as well as the NPV and IRR for the two projects are given. For both projects, the required rate of return is 10%. Project 1, initial outflow, inflow. This is NPV, this is IRR. For project 2, the cash flow occurred at the end of year 4. No cash flow in the third year, in the first 3 years, and NPV is higher and IRR is lower. What discount rate would result in the same NPV for the both projects? One way to solve this question is a shortcut. The rate at which the NPV for both these projects will lie somewhere between these two. But that will be tuka. The right approach to do the way we do it in CMA is to take the differential of cash flows and calculate the IRR that brings those cash flows to 0. If you calculate the difference, 36 minus 0, 36. 36 minus 0, 36. This will be 0. 36 minus 0, 36. But 36 minus 175, it will give you negative 139. So these are the differential cash flows in project 1 and 2. What is the specific rate that will compute these differentials to 0? Would be the IRR. So punch in these numbers in your financial calculator. Punch in CF0 0, your cash flow year 1, year 2, year 3, you can write the frequency one, and then this one for the 4th year. And calculate IRR. You will get the exact result. It's going to be 13.16%. So take the differential cash flows and calculate the IRR for these cash flows. 0, 36 positive, 36 positive, 36 positive, negative 139. Calculate IRR. So this would be the rate that will equate these future outflows and inflows to 0. That is the rate, gentlemen, that will give you the same NPV for both projects. So if you calculate NPV using this rate for project 1 or project 2, your NPV in both cases will be 6.73. It has not been suggested in your solution in the curriculum, but that's the suggested approach. You can use this method to calculate both the NPV as well as the rate at which both give you the same NPV. Moving on to the next question. Wilson Flannery is concerned that this project has multiple IRRs. negative 150, 100, 0, negative 150. Cash flow is changing direction. This is a non-conventional project. How many discount rates produce 0 NPV for this project? Since the cash flow is changing direction from negative to positive and then again from positive to negative, so there will be 2 IRRs. When you will use your calculator, your BA plus, it will give you just 1 IRR. These numbers, when you enter, you will get 0 IRR. It means all of these could be the right answer, since there has to be a second rate as well, which could either be 32 or 62, right? What you can do here, because your calculator will give only 1 IRR, not all. So what you will do, simple, it's not a big deal. You have financial calculator, just punch in the numbers, tuck, 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 you'll get your result. So use 32% for these cash flows. Using 32% will give you a positive NPV of 4.018, which means it's not right. If this is the IRR, the NPV should be 0, which it is not. But when you use 62% as your discount rate, your NPV will be almost 0, since it's not the absolute. So it means that this combination is correct. So these 2 IRRs are possible, 0s and 62%. That makes C to be the correct option. With regard to the net present value profiles, as you can see, of 2 projects, the crossover rate is best described as what? Crossover rate. Let me bring it closer to you. Now look at this. The rate at which both of these projects, project A or project B, both projects are giving the same NPV. So basically the crossover rate is the rate at which A and B, or many projects that are being considered in this arrangement, they will give you the same NPV. 2 projects have the same NPV. The rate that gives you the same NPV is called the crossover rate. So that should be your right answer. 2 projects have the same NPV. No need to look for option B and C. It's a straightforward textbook question. With regard to net present value profiles, the point at which the profile crosses the vertical axis. The profile crosses the vertical axis. It shows what? It shows NPV. The point at which 2 projects have the same NPV, no, that's the crossover rate, this one. The sum of the undiscounted cash flows, because on the x-axis we have the cost of capital, right? If the discount rate is 0, what does it mean? We are simply adding up all the cash flows. So here you have, when the curve cuts the y-axis, this point shows simply the sum of undiscounted cash flows from the project, because the discount rate has been used as 0. As you keep on increasing the discount rate, NPV starts falling. A point will come when the NPV becomes 0. This point where the NPV becomes 0 is IRR. Remember, so where it cuts the x-axis intercept, this is called the IRR. Where it cuts the y-axis, that's the sum of the undiscounted future cash flows. So that makes B to be the correct option. With regard to the net present value profiles, the point at which the profile crosses the horizontal axis, cuts the horizontal axis, that is the IRR, the project's internal rate of return when the project's NPV is equal to 0. Straightforward, C is the right result. Finally, with regard to capital budgeting, an appropriate estimate of incremental cash flows from a project is least likely to include what? Externalities, yes, considered in capital investment projects. Opportunity cost, what you sacrifice for the project, yes, it is considered. Interest rates or interest cost, no. Why? Because the interest cost is already embedded in our discount factor. If you consider the interest payments as well, that will be double counting. So that's why interest payments are not considered. So that makes B to be the least likely one.